Right. Hi, and welcome to our final presentation. We are Stegosaurus. I'm Brendan, the apper. This is Abhishek, Dhaval, the developers. Stegosaurus is a different kind of password manager. So what is a password manager? Well, password managers are software that allow you to store and manage your passwords so that you can use a unique, strong password per account. They do this using cryptography to scramble your information. But what we're doing with Stegosaurus is we're actually using a method known as steganography on top of cryptography. The goal through using steganography is to allow you to store your account information inside pictures, actually by hiding it inside pictures, and then the user gets that account information back if they both select the correct picture and the correct account tag that the user is assigned to that particular bit of account information. We also want to make passwords easier to remember by doing this, because the user can then just remember the picture in which they stored it rather than the password itself, which is a much easier memory task. What is steganography? Well, steganography is the name for a class of formal methods that hide or obfuscate information. It actually has a very long history. The name is ancient Greek for concealed writing. Some famous historical examples are Da Vinci's mirror writing, as well as microdots, which you can see that tiny little piece of information there is actually pulled out of that period there. We are using a form of steganography known as picture steganography, in particular an algorithm called Hugo for highly undetectable steganography. And as you can see, it takes a base image here, and then this is the image using Hugo to hide text, and they're visually indistinguishable. So, why steganography? Well, as this comic amusingly points out, there's one problem with cryptography, despite it being fantastic and an essential part of any security scheme. Cryptography is detectable as cryptography. What this does is it means in sort of the current way that certain jurisdictions are going is they are writing laws to make illegal or restrict the possession and use of encryption no matter what you're doing with it. And so steganography, unlike cryptography, is almost impossible to detect. It just makes your device look like it has normal pictures. And two, as mentioned before, images are easier to remember than text. So that's also why we're using steganography. Talk to you about the overall design. I'm going to hand it over to Dhaval.
So the application is centralized around the key idea of obfuscation. So within our application, we have implemented 3 obfuscation layers. First one is encryption obfuscation. It basically hides the fact that there exists any encrypted data on the cell phone. Content obfuscation, as the name says, it hides the content inside an image so that anybody will not be able to tell that there exists any content inside the image. And access obfuscation hides the access control that we have implemented within our application. So another key decision we needed to make was how to gain users' trust. So in order to achieve that, we performed formal usability testing to get the results, and based on the results, we have updated the designs, and we have also implemented access control. So this will allow the users to have the control for the application. We also store all the information within the phone itself, and we don't store anywhere on the server. This mainly protects any data leakage or any user trust issues. This is the overall high-level block diagram of how the application flows. So in general, users will communicate through user interface component. It will either store or retrieve passwords. The user will then select an image, and based on the image selection and the actions, Stegomaster perform appropriate either to encode an image or to extract the information from an image. Now I will hand it over to Abhishek to show the demo.
So this is our application, Stegosaurus, and this is the first screen that's going to show up when you open our application. And so this is going to ask you to set up your access control. Access control is basically like a layer of authentication, so that every time the user logs in, he needs to remember the master picture and master password. It's kind of your login information. So let's set that up. So let's choose a picture. So we can choose any of these pictures. I'm going to choose this picture here. Let's choose a password. And then once we're done, that's my password. I'm going to click login. So this now my login information is entered into the app. So now let's re-enter the app after the access control has been set up. So it looks like this, just looks like a normal gallery. So now you have to choose the correct master picture and type in your correct password in order to gain access to the application. And once we've gained access to the application, we have the main screen, which you guys saw last week. So now we can store our information. So let's store something like our Google account. So this is the account page where you choose which account you're going to save. So let's store our Google account. So let's say mine's called ECE test. And so a random password has already been generated for you. But let's say I want to have my own password. I would type my own password in and confirm it. And once I'm done, I would save my information in the picture. And now it's going to pop up and ask me if I want to save the image file that I just created. And this will actually overwrite the original file so that we don't have duplicates. So now, let's say I want to retrieve my information. So the picture looks exactly the same as before. There's no duplicate images. And so if I want to choose an image, I would have to choose the correct account type. So if I don't choose the correct account type, it will say no data found. So this is the obfuscation that we were talking about. So if you don't choose the correct account type and the correct image, you won't see anything. So now let's choose Google, which is the correct account type, and it'll show you your password and your account name. So there's my password. And let's say I want to log in, so I would copy it to the clipboard, and then I would go to my Gmail account and paste it, and then sign in. And that is, now I'm signed in. So now I'm going to try retrieving a password from another picture, but this picture was embedded on another phone. So Brandon sent me this picture through Bluetooth earlier, and he used the same exact application to embed it. So let's go to the Bluetooth folder and try to extract information from this. And he also used the Google account, and it'll say no data found. So even though we use the same application and the same account type and the same picture, you won't get any information. And now I'm going to pass it off to Dhaval to talk about key learning.
So during the developmental process, we learned many things. So one thing we learned the most is that we spent way too much time implementing the algorithm, Hugo algorithm, which the source code was not readily available completely. So what we thought that we could have used another algorithm, F5, which it already exists in Java. So we could have implemented in parallel with the implementation of Hugo, so that we have a fallback plan. We could have also performed more usability testing to get more to get more insights on the trust, and informal code audit by security organizations such as Citizen Lab.
Okay, and just to end, so we would like to continue working on this, primarily with cross-platform development and improving access obfuscation. And as you probably noticed, we need to clean up some stuff with how the history, the timestamping is working on the images, so that that is obfuscated as well. As well as security auditing, Hugo can work on multimedia, so we're going to do that as well, and Google Chrome extension to allow you to actually use your password management cross-device. Okay, thank you. Any questions?
It's great to see it come together in an actual app. That's, after previous ones, that's really good. I have a couple questions. You said earlier on that you did user testing, but
Yes.
you didn't talk about that.
Yeah, we did it we did it right after Spiral 4.
And
So
what
that's
did you do?
So I did the usability testing.
So you were the user?
No. So I recruited users from
Nice.
from people that I knew, and so I ran them. I walked them through a set of standard scenarios that I constructed, and then I had them fill out a pre-session screening questionnaire just to control for their background. I only did 4 users, which is actually not bad, but we would like to do more. And then I had them fill out something called the system usability scale at the end to assess how well they've found the experience of using it. And then I also had them talk through what they were thinking as they used it.
And so did you change anything as a result of what they did?
Yeah. I mean, so that drove home sort of how important access control was, and we really had to focus on making them feel secure and comfortable using the app. And it also reinforced that the kind of the simplicity of use was really important, and sort of the core functionality that we had, they liked. They were able to figure out how to navigate that quite well.
And just one last question for me. At the very beginning, when you entered the primary password, you had to pick the picture
Yes.
and put the password in.
Yeah.
Yes.
Why both?
So what users, so like for usability testing, what they wanted was they wanted a password, even though like they were just like, they couldn't like see the security in choosing an image because they were like, well, anyone can just go through all the images and then log in, right?
Yeah.
So then we were like, okay, so we have to add a password as well as an image, just so that users feel more secure in using the application.
And we use the same technology. We store the password inside the image itself. So
Understood.
Yeah.
Probably should have explained that because it seemed immediately and utterly contradictory.
Right.
Yeah,
Yeah. That was. Yeah. For.
Does having your app pretend to be a gallery when you first open it, does that lose some of its power when as soon as you click an image, instead of it getting bigger, it just asks you for a password, which is a very strange thing
Yes.
that happens?
Yes.
So we still have to
Yeah.
work on that.
Yeah, this essentially the stage we got to here was
Yes.
we wanted to show that we were figuring out access obfuscation.
Yeah.
So yes, having it actually push to just showing the image is part of what we needed to do. That turned out to be a little challenging, so we're actually still working on that. And we also actually want to make the fact that the app is even installed on the phone hidden as an additional layer of obfuscation.
Really raucous crowd we back home today.
Working too hard.
All these deadlines and comments. Yeah.
I thought like the user interface looked really good, like really streamlined and well done. So I really like that.
thank you.
All right.
The comment, I really liked it. I just think it would be so cool if we could actually I could go into the app, or I could use it in other apps. And I know I would actually use this if I could do that. Do you guys know how you would do that?
You mean like
from-
connected to
So
something?
Multimedia, like multimedia hiding, or
Like if I was in another app somehow, I could click on the password field, and I don't know if this can be done. You guys know.
Oh,
So that's why the Chrome. So we know how to do it under the desktop version. That's why we'll add a Chrome extension or Firefox extension so that you automatically send the password. But we are still in the process of figuring out how to achieve that in
Android.
the Android or the mobile devices.
I think it'd be really cool.
Well, all the competing apps have copy paste like what you have.
Yeah.
Yes.
Is there anything? Does anybody have anything that lets you do this easily?
You can't
Yeah.
without a rooted device.
right? That's the
Yeah.
problem.
Yeah.
It's not possible.
It's,
Yeah.
yeah.
I mean, it's possible, but it's not possible efficiently.
Yeah.
Yeah.
Melissa?
I like the idea of bringing it to the citizen lab. I think it would make it really great, and I think they'd have some interesting perspectives on it, and you
Yeah.
guys
Yeah.
could really take it further with them.
Yeah.
Yes.
Yeah.
Is this the first like app of its kind?
There's other ones, but they're mostly it's like you hide a message in a picture and you send the picture to someone else and then they would decode it. Whereas ours is more security based, theirs is more like message.
So the other applications are more really simple, like probably they've done for the project, and they were using F5, which the algorithm already exists. It's a really weak algorithm. So
Yeah, we're using a much more sophisticated
Yeah.
form of algorithm on top of doing other stuff. Most of the steganography that exists, as mentioned, it's almost like a toy, which is great. But you hide a message in a picture, and then you create a picture you can send.
So I think his question was, does anyone else use steganography to hide a password? Is that what you were kind of
On
getting
an
at?
app.
Oh.
No, that's kind of what he was asking.
So
No
then
passwords, no.
this would be the first of its kind.
Yes.
Yeah.
Cool. Great. Thank you.